Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. So in the project today, I want to try to understand customer feedback for user experience teams and for product development teams. And we're going to collect feedback from Amazon products and information about what these products have delivered in terms of enjoyment or dissatisfaction or whatever on a few different levels, and collectively ingest all of this feedback into different types of NLP techniques, so natural language processing techniques, and try to identify pain points and fix problems quickly so we can communicate the issues again to user experience teams and product development teams, try to drive information to improve product development, improve customer experience, keep on track with customer sentiment and changes over time, and try to address these issues that people have with various products, and basically personalize marketing campaigns and personalize messaging to the customer to enhance their experience, to deliver more meaningful, more practical experiences for the end user. And we're going to try to quantify the voice of the customer at scale. Okay. And the overall goal here is to assist the user experience teams and, again, product development teams for the purpose of making improvements to existing products, right? To enhance the user experience and deliver more value to the end user. So I went ahead and loaded data from the CSV file that I found on this, where does it come from? Kaggle website. Okay, if you go over here to this Kaggle website, I will give you the link to the data source here. So Control C, Control V, paste that in there, and you will see the source data over here. So you can download that and copy and paste the code. I'm going to share all the code with you. Download this black button over here on the right, and I will share all this code with you, and you can follow along at your leisure. Okay, so we're going to import some basic dictionaries here, not dictionaries, libraries here, and we're going to use TF-IDF vectorizer, stopwords, natural language toolkit, and things like this. So I put the CSV file on my desktop. If you want to take a quick look at it, I can introduce you to that data affinity. Let's see, it's called data affinity, and it looks like this. Okay, open it, and I think all of the reviews come from column Q or U. I think it's U, like universe, or U like YOU. No, that's Y. U like universe, right? So if we go over here to column U, and we have reviews.txt, and you can see some of the reviews over here. Oh, it's on the other screen, sorry. So you can see some of the reviews over here. If I expand that, you will see what people are talking about. I thought it would be as big as small paper. Okay, that's one review. This Kindle is light and easy to use. Didn't know how much I'd use it. I am probably 100% happy with my purchase, and solid entry level Kindle. Okay, so we have all kinds of Amazon reviews here. We're going to take that and assimilate that in a few different ways and try to make sense of what people are responding to in terms of their reviews for all these different Amazon products. So the first thing we're going to do is get everything to lowercase text, so everything is standardized and uniform, and we can analyze it a little bit more efficiently, a little bit more predictably if everything is standardized in the same format and consolidated into lowercase text. It's going to be easier to do this type of analysis. If we have uppercase text and lowercase juxtaposed next to each other, they're actually different. We want everything in the same uniform lowercase case, for lack of a better word here. We are going to use tokens to go ahead and take the text and split that based on the space between all the words. And we're going to take each of these words and tokenize them. Tokenization means we're going to create numerical representations or vectors of these words. Okay, so the computer doesn't know what Kindle, the, happy, dissatisfied, doesn't know any of these things. It doesn't know the meaning of these terms. But if you can take a term, an English word, and convert that into a vector, which is basically a numerical representation of that word, take that and parse everything out based on splitting the tokens, and then we're going to go ahead and use stopwords in the English dictionary to understand what are the most meaningful pieces of syntax here. So words like a, the, and, Yep, just like those don't add anything to the meaning of the syntax or the purpose of the sentence, right? So we're gonna go ahead and take out all the stop words, the, and things like this that don't add any real meaning, and just understand the true purpose of this text. Like, what is this text trying to communicate to us? Okay, so we have that column called reviews. I just showed you that. We're going to go ahead and take everything called pre-process, Control C, Control V. This comes from a user-defined function over here. So we're going to apply everything in this UDF over here. That's text. Text is going to come from lower, splitting the text, get rid of stop words, so the, and, or, but, things like that don't add any meaning. And then we're going to take everything and then rejoin it together once it's been cleaned up. Okay, based on that final cleaned up, scrubbed text, we're going to take TF-IDF vectorizer and vectorize all of these text words, right, to create a numerical representation of the word. And we're going to put that into a variable called X. So everything is cleaned up, transformed, stop words are removed, and then we join everything back together. So we have numerical representations of these words that are meaningful and have an actual purpose. And then once this is all cleaned up, we're going to go ahead and take these X features that came from over here, the vectorizer feature. So everything is vectorized, numerically represented. Substitute the text for number representation of that text. We're going to fit that into k-means and make predictions. And based on the predictions or how similar or dissimilar these different pieces of text are, we're going to cluster them together into relevant text, relevant clusters that match other clusters, right? So basically, in a nutshell, clustering takes the numerical difference, or subtracting a minus b, b minus c, c minus d, x minus y, y minus z, and so on and so forth, taking the distance after we subtract the differences from those, the words or the text that has the least difference goes into one cluster because they're the most homogeneous. Clusters that have the most difference or more differences among all these text clusters are going to go into heterogeneous clusters, right? So because they're different, they're similar to their own cluster, they're homogeneous amongst themselves, but they're heterogeneous to other clusters, right? So all clusters are homogeneous, get clustered together. Everything that's heterogeneous or different gets clustered into its own different cluster that represents those words the most closely, right? They're the most similar, they're the most congruous, right? If they're incongruous or heterogeneous, they go into their own cluster, okay? So hopefully that makes sense. So we're taking all these variables that we got from vectorizing all the text over here, right? So we have clean reviews, which comes from reviews. Take all the reviews, clean it, clean reviews, vectorize it, put that into this variable X, and then we're going to take k-means and cluster everything together. So all the similar clusters are going to be together. All the different clusters are going to be clustered into their own cluster. So that's how we do that. We're going to come up with 10 clusters. We're going to use slicing, a slicing technique right here. If you look at the colon right here, the first part of the colon is the start, the end, or the second is the end, and the step is how we go through each cluster. So you can step one, if you go through every single element in the string list here. If you go through 2, you would go every other one. 3, you can skip 3. You could do 5, 10, whatever you want. So the last argument here is for the skipping of the number of steps. The second is the end, and the first is the beginning. So we get 10 clusters. We get everything from the beginning to the end. As we're sorting this is argument sort, and we're getting the top 10. So if you want to look at slicing, I think that would be a good idea, just to get a better appreciation of how slicing is done. And you can see here, this is the start before the colon, the stop is in the middle, and the step, whether it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever other steps you have, that is going to be how you step or iterate over the different pieces of the string, right? So if you have my list, you start at position 2, you end at position 5, and position 2 through 5 would be, let's see, start, output 2, 3, 4, start at 2, 2, 3, 4. So you start 0, so this is 0, 1, this is 2, 3, 4, which is actually 5 because you start at 0. So the 4 is the 5. Everything in the Python world is 0 based, so you just increment by 1. If you go 1, 2, 3, 4. So the beginning to the end would give you 0, 1, 2, 3. So 4 steps would give you the beginning. There's no beginning. You start at the beginning, you end at 4. And if you print 7 into the end, you can start at 7 and go to the end. So 1, 2, 3, 4, 5, 6, 7. So this would be 6, 7, 8, 9. That would give you 7 through 9. And again, if you start at the beginning, go to the end, skip 2, you would have 0, 2, 4, 6, 8. So even, 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 even. Okay, so if you have any questions about slicing, that's how you would do it. So let's go to the next step here. So we have TF-IDF shape. We have 5,000 rows and 5,773 columns. Okay, and I'm going to go ahead and do the clustering, like I said, and I have the beginning and the ending step -1. So we start at the end, go back to the beginning, and get the top 10. So cluster 0 says, was looking for a tablet to read books, and this is perfect for me. It's a nice upgrade for the 6-inch screen size. It's just right for the kids. And handwritten Kindle is much easier. It was very difficult to set up with 3 hours help of Geek Squad, and my granddaughter hopes iPhone get it done. So you can see here, the first piece here is in quotes. Then you have a comma separated value. Then the second piece was over here. It's a nice upgrade. And tablet, these are the cluster terms: tablet, loved, bought, Kindle, one old like, fire, gift, year. Okay, so that's cluster 0. Same thing for, or similar for cluster 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. So we have 4 clusters. Like, yeah, 4. Where's the for range of 5. Okay, so we're doing 5 clusters, 0 through 4. So we're doing 5 clusters. If we did 10, we could go over here to 10. Then we'd have 10 clusters. So 0, 1, 2, 3, 4, 5. Oh, I think I only put in 5, right? Like I put in 5. So it's 5. Where's my 5 over here? Oh, clusters equals 5. Okay, so I'd have to put both of these, change both of these, and now we'll get my 10. Starts at 0, 0 base goes up to 9. Cluster 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's cluster 9. I love the fire and the fact that I now have a place for my library. That's not taking up space on the phone. And you can see, again, anything between quotes is the first comment here. Then you have a comma, and then you have the second string of comments, again, going into cluster 9 because these are similar, right? So the person had a good experience. Love, one, bought, like, used, books, screen, great, get, games. So all these terms are somewhat similar. If you take the k-means distance, subtract the numerical representation of love, one, bought, like, used, these are all going to be syntactically mostly similar. So they get pushed into the same cluster. Overall, this is positive, right? I love my fire, Kindle, easy to use. These are positive comments. Bought this tablet for my 5-year-old, so on and so forth. The point is, like, if you have a lot of positive terms, the ones that are most similar are going to go into the same cluster. If they're heterogeneous or different, right, or dissimilar, they'll go into their own separate cluster. If you have negative terms that somebody was upset or frustrated by the experience of the item, that the experience that the item delivered when I bought from Amazon, those would guarantee to go to a totally different cluster from experiences where people enjoyed the item that they got from Amazon, right? So negative experiences and positive experiences, or negative will go with negative, positive goes with positive. But you can have several types of negative and different degrees of negativity. Same thing with positive. You can have very positive, mostly positive, somewhat neutral, not quite as positive, but still kind of have a positive theme. And those can get clustered together. But you'll see, like, the most positive and the most positive together, most negative together, neutral and neutral together. You'll see the clusters being somewhat similar. So let's go down here and look at UMap. This is a way of looking at the neighbors, again, looking at the similarity of components. We have 2 components. We have the array here with the first and second component separated by a comma, second components here, third, and so on and so forth. Okay, now we can go ahead and look at topics, again, using English-based language, and we're looking at BERT. So BERT is a topic organizer, and it helps us to fit and pre-process data together based on how similar these topics are. So if I do a quick Google search for BERT topic, what is this doing for us? BERT topic is a topic modeling technique that leverages transformers. Again, TF-IDF, this is text frequency, inverse document frequency, to create dense clusters based on the similarity or the interpretability of topics and how similar the topics are, they will get clustered together. Or if they're dissimilar, they go into their own separate cluster where the topics are similar to those relative topics, okay? So that's what we're looking at here. We have the topic model and we're using the English language. There's different languages you can use, right? French, Spanish, we're using English words right here to tell the model which types of libraries that we need to leverage, right? And we're looking at fitting the transform. Again, looking at this field in the data frame, this was called reviews. And as you recall from before, reviews is a cleaned up representation of where is it? Apply progress rate. We took out all the capitals and lowers and converted everything to lower, split the text based on the space between the text. So we know how to tokenize different words. We are doing all the tokenization over here based on English language and then joining everything together to get a cleaned up representation of the reviews from Amazon. All the reviews go into cleaned reviews, and then we're transforming the text, right? That's how we get the X, and that's how we're doing the clustering, okay? So hopefully that makes sense. So yeah, so running here. I think this should be done pretty quick. It's finishing up, completed, embeddings, it's completed. Dimension only fitting the dimensions. It's doing the reduction right now and clustering, and then all representations are fine-tuning using topics, representing the models that you saw before, and the representation is complete. Okay, so now we have a complete list. Now we have the original name, the representation, which is a new column that we just created over here, and the representative documents based on what BERT topic modeling was on, right? So Google it if you don't know that. BERT looks at topic modeling that leverages transformers, TF-IDF to create dense clusters, allowing for interpretation whilst keeping important words in the topic descriptions, okay? So let's move on here to the next step. And we have the topic, the first 8 topics. So we have actually 10 topics. One was negative. And we have 0 through 8. So 8 would be 9, and this would be the 10th over here. We have the counts over here of each one, and then the overall name, the, to, and it. So this kind of looks like kind of nonsense. It's not a whole lot to it right there. Not very descriptive, not very meaningful. Kindle is my best item or whatever. Alexa shows music. Gift love for Christmas. Tablet for kids. Product great recommendation. Tablet great price. Camera screen, picture clear, sound speaker great, setup easy, okay? Then you have that representation over here of all the words that back up the naming convention used over here in this column, and the representative documents, great product, so that's positive, great quality, screen is good, like the price, good product, and great tablet, okay? So we have some positive comments down here. Now we can go ahead and use visualize the topic using a topic model. This interpretation, or this interprets a distance map in visual representation using topic modeling. This uses latent Dietrich's allocation. That is pretty cool. I would invite you guys to check that out if you haven't seen this. Latent Dietrich's allocation model, and I was gonna look for one example of that. I don't see it here, but that's okay. It just takes everything and then breaks down the comments into representations based on how similar or how dissimilar they are. So each circle represents a topic, okay? And the size of the circle represents the relative importance to the topic of the corpus. So you can have words like the, is, my, fire. So some of those don't really mean a whole lot. Is and my and the don't really add anything, but fire could be Kindle Fire, right? That can give us some information about the product that we're looking at. Charges Kindle, charges quickly. Okay, so these topics are pretty similar. If we go down here and move the bar to the right, you can see the colors moving around here as we move the what's it called? The slider over here. Gift loves Christmas bought. Okay, 255 represents how important that is to the overall corpus of text. And again, we move the slider and we can see the focus for these different topics. And again, where they fall in the different quadrants, right? So distance between circles shows the similarity or dissimilarity between the topics. Big distance, more dissimilar. Small distance, more similar. Closeness together shows the topics sharing similar words and meaning, and far apart means the topics are distinct and separate, right? That's how you get these 4 different quadrants spread around here. And this shows us whether the topics are redundant or overlapping. If they're similar and close together, they're very homogeneous. If they are far apart, they're very heterogeneous. And this reveals if some topics are too broad or too narrow. Okay, so let me give another representation here. So we have topic models, get topics, topic 0 and topic 10, right? And we have, I don't know how many topics, so 65 or maybe 70 topics all together. This is topic 0 right here, Kindle, the, is, it, to, reading, okay? And topic 10 is show, echo, video, music, sound, and so on and so forth. So we can go ahead and append topics onto the data frame. We have the original data frame. If you saw that over here, this is what it looks like. Oh, I didn't even show it. Okay, so anyways, the data frame is sitting in memory in the background. When we append a topic onto that data frame, you can see it goes to the end over here. We have the cluster that we did over here. This cluster comes from where is it? Oh, here's it, DF cluster. So this comes from predicting the TF-IDF vectorized variable. Remember, we vectorize everything over here using TF-IDF. This becomes X. This is the cluster. Okay, if we go down here, we'll see the cluster number. It is represented right here. That cluster is appended onto the original data frame. So this is cluster 3, cluster 6, cluster 3, and topics are appended over here. So 0 topic, 51, 0, 0, and 0 topic is again appended onto the data frame. So this is all the pre-processing data. Now it starts to get pretty interesting. We're going to use a technique called text blob, where we use the sentiment and the polarity. The sentiment is either positive, negative, or neutral, and the polarity is how how polarized or how maybe offensive, I don't know if offensive is the right word, but how important or how polarity is kind of like significant, how significant or meaningful something is, right? So we're going to look at the polarity of these reviews and try to drive the meaningfulness or the importance of this text. And the sentiment, again, is positive, neutral, or negative. So polarity is how important or how meaningful something is, and sentiment is positive, neutral, or negative. So we can see the information down here. All right, as we parse that, we are using cleaned reviews based on topic. We're aggregating all the topics together, grouping by topic, and applying a pain point. So we can see a summary of everything that's been done here. We have 66 clusters, okay? And this is the pain point. Bought Kindle months ago, already dead. So that's a pain point for this guy. Thought it would be big, small paper. I don't know what that means. Like to show, can't say, love prices, okay? It's not really English words, but barely. Something fun, family play, may get boring. Got sales replaces, CD must buy long prime. Again, barely English, but I guess I qualify. Son loves my tablet, plays games without making something, okay? So total in topic 1, 329, pain points, 13. So you have a lot of topics here taking up a lot of space, but the pain points, we're looking at how painful it is. So in the topic, we could have positive, neutral, or negative comments. That's a sentiment, right? And a pain point would be some kind of negative comment that's causing some kind of distress or discomfort for this user. And they're stating that, they're vocalizing that in their review. So here's the reviews put into a list, and we're looking at all the reviews together. Okay, so review 1, great gift for everyone. Review 2, well designed. Review 3, it was a little hesitant to spend money on this. Review 4, I only have this because my Amazon Echo showed it for a couple of days. Okay, so we have down to review 26, what I expected. 27, love Alexa and its features. 28, disappointed it doesn't have a mirror display mode. And 29 through 29, love the communication with Alexa and the new home display. Okay, so everything has been refined, updated, cleaned up, right? We got rid of the stop words. We convert all the uppercase to lowercase. We are looking at sentiment and polarity, right? So we're cleaning up the text, and now we can make a final assessment about what's contained in this text, including the pain points as well. So I'm looking at cluster ID number 1. So how many clusters do we have? I think we had 10, right? Cluster number 1, replace with any cluster number for I and text to enumerate through all the clusters. We want the cluster ID, that's number 1. Okay, I'm just arbitrarily picking 1 just to show you what it looks like. And we're looking at cluster ID and the pain point, and then the value. Okay, so again, we're looking at slices, and we can see all the details down here. So review 1, wife loves, has been always hesitant to try ebooks. Review 2, want to read anytime there's light source. So again, like if we go back, we're looking at all of the topics, all of the reviews, 329 reviews for cluster ID number 1. And in terms of pain points, is 11 pain points. So 329 reviews overall, 11 of these 329 are kind of negative. The person had a bad experience, right? We're trying to tease out the bad experiences, find out what's going on here, and try to rectify that or resolve that somehow. So 329 minus 11 is 328 minus 10, 18, 318 positive reviews, but 11 negative reviews. So we can ignore the 318. Most people had a good review. What we want to try to understand is this customer feedback for the user experience team so they can make improvements to these products, because there are some pain points here and people are a little bit frustrated with their purchase, right? And for the product development team as a whole, these two teams can work together. The UX team and product development team can collaborate and try to figure out of 329 comments, and we had 11 negative comments, what's going on here? Purchase son, loves to read books, showing, sat down, would figure, thought reading books, would want 1. I don't think that's super negative. Maybe we can drop it. But small reader wanted something larger, so maybe it's the size of the what is it, reading book or whatever this thing is, Kindle, something, right? Birthday family member loves reading books. Amazon gift card endless. I don't think that's negative. We can probably ignore that. Wife loves reading nonstop. Can't put, maybe can't, got picked up as a negative word, but I think that's not really a negative comment. Voyage light battery, 2 weeks. Maybe he's complaining about the battery. Decent reader, beginning, backlight, good reading. Like e-reader, small, increased font. Okay, so anyways, these are the 329 reviews, and what happened? Most were positive, 318 positive, 11 negative. Let's look at topic number 10. So I'm going to change this slightly. Okay, we had 329 and 13 negative, right? So control enter. Now we have 65 topics, 2 negative. Let me see what the 2 are. Refresh this. So here's all the comments, 65. We'll have 65 total. 329. Did I not get that right? Oh, I had number 1 again. Right. Let me do this again. Okay. Now we should have 65. If we go down here, 64, 65. Okay, start with 1. Did we start with 1 or 0? Oh, we started with 1. Okay. So start with 1. Enjoy. I bought Echo to make my family take pleasure in it. And let's get the pain points. Remember, it's 2 in this case. So here's 2. Download slow and didn't make worth stand alone. Echo slow, feels useless. So here they're complaining about the speed of the overall performance, and it's just slow for these 2 people. So 2 out of 65 had a complaint, slowness. 63 were fine. 2 said they're slow. Maybe it's an arbitrary thing. Maybe this guy thinks it should be faster. Maybe it performs very fast. If 63 of the 65 people say the speed is not an issue, maybe the UX team doesn't have to do a whole lot. Maybe the product development team doesn't have to do a whole lot. Maybe these 2 people were in a bad mood one particular day when they wrote the review. Who knows? It doesn't seem like there's a systemic problem recurring over and over. Let's look at one more example here. I'll take topic number 5. Topic 5. Okay, so I get all the topics. Whoops, that's 5. I hit the control. I didn't mean to do that. So we have 151 topics, 4 negative. Let me get the topic 5 over here. Cluster 5. Okay, so here's 151. Start with 1, go down to 151. 151 reviews in this cluster. This is a great tablet for the price. Let me put 5 down here. I think we had 4 negative comments, right? 4, control enter. Let's see what they say. I'm disappointed, sometimes doesn't understand. Maybe that person doesn't understand. I'm not sure what he's talking about. Kept freezing, ended, return disappointing. Bought gift, wife loves works as expected. So that doesn't seem like a negative comment. I would ignore that. Probably ignore that. Kept freezing. Maybe we want to look at that. Maybe the UX team and the product development team have to consider building something in if the product is going slow. Maybe gracefully stop whatever process you're starting, whatever process you're running, and restart another process, or just refresh the process. Maybe something has to be built in to gracefully stop the process for a long running item. If it takes a long time to load up, just stop it and then go back to the start screen after you do a refresh. Maybe that is a takeaway here. Horrible, just like owned do warranties. It says horrible. Not sure what this warranties thing is about. Bought Christmas gift. Wife thinks things started well lately. Wife issues, hasn't working. A little much. She's going to try hard. Reset, sees help. Okay. So some of these you have to take with a grain of salt. I don't even know what this means. It seems like it's English. It's not really meaningful or really has a purpose. But anyways, to take all of the feedback, clean up all of the text, and get this in front of the UX team and the product development team, I think this is a worthwhile exercise. I think this makes sense. And I think this is something that we need to consider for process improvements, for improving, the durability of the product, the speed, the processing power of the product, the overall experience, the look and feel of this item that this person purchased from Amazon, and just look into it. Maybe nothing can be done, but there's definitely some pain points here. People are struggling with some issues here. It needs to be looked into, and it needs to be exposed. Is this going to be addressed or not? That's a different topic. But at least now we know what the pain points are. We know what the issues are. We know some people are experiencing some frustration about the product. Was it just made up and just kind of like some kind of fictitious experience that somebody created in their own mind? Or is this a real problem? Maybe we can have the UX team and the product development team take some of these Kindles and try it themselves and try to replicate the process and see if this is a real issue, or maybe this is a one-off. Anyways, we have information, we have insights, and we can do a deeper dive into the discovery of what's causing these issues. Are these real issues? Are they meaningful? Is this really something that we can fix? Or maybe it's just somebody had a bad day. Maybe it's some weird thing with the Kindle, not in a great state. Maybe you just have to power off, start it up again, and everything will be fine. But anyways, we have some information to work with. We have some food for thought. We can go ahead and try to unpack this a little bit more and understand what's really going on and what are the real pain points and what are the more kind of maybe perhaps I would call them imaginary pain points that don't really exist. Maybe a person had one bad experience one time. Maybe the system had to be restarted. Maybe the person didn't even know how to use the device, right? They're just in the learning phase and they made a couple of mistakes. It's actually their fault, not the product's fault. But anyways, we can expose these things, right? The pain points can be exposed, and we can try to remediate them and address them and fix these problems on the next release, or maybe fix the software and push that out, and everybody in a week or a couple of weeks can have a better experience, right? So that's what it is. Bubbling up these problems to the surface, addressing the issue, and remediating the issue. That's the point of this. So hopefully that was useful, good use of everybody's time, and meaningful, and served a purpose too. I like to work in these different case studies and these different projects, and see where it goes, see what kind of things you can discover, and see what comes out in the in the process when you're doing your analysis. So that's it, guys. I'm going to wrap it up here. Hopefully that was enlightening and useful for you. I learned several new things actually, putting together the code for this process, and hopefully you did too. Okay, I'm going to share all the code with you guys in a little bit. When I drop the video later today, you'll have all of this Python code in HTML format. You can download it when you download the video or when you view the video, and you can run these code snippets and these code scripts on your own machine by yourself at your own leisure. Okay, thanks for your time. I'm going to wrap it up here, and I'll see you in the next video. Goodbye for now.